This is session 5 on the Airbus A350 flight control system. We are now going to be talking more about the actual primary flight control system. And if you think about the A350 and its flight controls, just think about two broad categories. We have the primary flight control system and everything else, which the other two systems we're going to be talking about are going to be the slat control system and the flap control system. Right now we're then covering every other control surface under the primary flight control system. So when we talk about flight control system, what is it? We are going to be talking, what that's encompassing is all the control surfaces except for the slats and flaps. So that would be your ailerons, your elevators, rudder, spoiler, your trimmable horizontal stabilizer, and also all the computers that are related to controlling those control surfaces. It also includes your speed brakes, okay, and your ground spoilers. Okay, so all spoilers, whether they're operating as flight spoilers or your ground spoilers. The idea with, of course, the primary flight control system is being able to have the airplane be flying safely in all directions that the plane flies in, right? All three axes. That would be, remember we mentioned before about the pitch, your yaw, and your roll. So the way that this is classified as far as the computers giving command orders is going to be in two different functions. Number one is your lateral function and then vertical function. Your lateral function, of course, is lateral, right, from side to side. So that would be your roll. Okay, your roll goes from side to side. And then also your yaw goes from side to side. And your second function is vertical function, which has to do with nose up, nose down of the airplane, right? So that's your pitch. So those are the two functions, your lateral and your vertical. Now, we know that the primary flight control system is a fly-by-wire setup, which simply means that you have computers that are getting the inputs, the sensor inputs from various sources, not just from the manual input from the pilot, for example, your side sticks, but also from your Ailerons and also your accelerometers, your remote gyro and accelerometer units. Those are all, sensor inputs to the computers so that they can control the control surfaces. So that's what it's doing. Your automatic flight system is where, those computers are receiving data. Now, there are different kinds of computers, but, we could, we talk about the control modules that are installed on the actuators. Those are also computers. But in particular, right now, I want you to think about two main ones. That would be your primary and your secondary computers. Now, what's the difference between the two? Okay, what do they do? What do they each do? Okay, your primary computers are going to be computing the commands, the commands that go to the actuators through manual control laws. They're going to be receiving and controlling in different modes of operation. Remember, talk about the flight modes, or your flight control laws, as Airbus actually likes to call it. Your flight control laws, for example, remember your normal, alternate, direct, and your abnormal laws. Those all those different modes is what the primary computer is going to be receiving inputs for to control. Whereas with the secondary computer, it's only going to be doing computations for manual, direct, law. Both computers are going to be servoing the control surfaces, okay, because you have the servo controls on the for the actuators to move the actual control surfaces. So both computers can do that. And then also the computations of auto flight orders are going to be coming from the primary computers. And the thing that's different with the secondary flight control computer, okay, is going to be its function with the pedal trim control through the pedal feel and trim unit. So it has interface with that. Okay, and just the abbreviation that you're going to see in manuals for the primary computer, or whether it's a secondary computer, is going to be PRIM for primary computer and SEC for the secondary computer. Okay, so I hope that gives you kind of a brushstroke on the functions of each of those and the difference. The secondary, in particular, the secondary computer is interfacing or having to do with the pedal trim control, where the primary flight control computers are not. Of course, all these the computers that are going to be sending, they're connected to the actuators through the flight control remote modules and also the electronic modules. And those modules are a translator, essentially, in the signals processing world or field, where they're able to, receive the signals, the digital signals coming from the computers, and turning it into an analog signal for the actuators to move the control surfaces. Okay, so that's giving you kind of a helicopter's view on the flight. When we talk about primary flight control system, that's what it is. Your computers that I just mentioned, the primary, and your secondary, abbreviated PRIM and SEC. And then also all the surface control surfaces except for the slats and flaps. And then lastly is all your controls. Okay, your cockpit controls, the sensors, so your Ailerons, your auto-flight system, and other components that may not be, they're just kind of manually or mechanically part of the system. For example, like couplers. All right, so that gives you kind of, again, that view on that. Now let's go ahead and let's go into the power, that's interfaced with the primary flight control system. So what what kind of power do we have going to this connection? Well, we have your electrical and your hydraulic. So on electrical, let's just look at electrical. The source for this is going to be the circuit breakers coming from the different buses that are 28 volt DC as far as their rating, and the primary, both the computers also with the remote gyro and accelerometer units are connected to those buses, that 28 volt DC. The exception will be the exception a little bit is on the power and field trim unit. That's connected also to the 28 volt DC, but it's through the SAC discrete command to control the relay. Or you have a solid state power controller that's depending on that that pedal field and trim unit channel. Okay. There's power lines that I'm mentioning right now are not the same as the MIL 1553. That's a different track electrically. So these are power lines separate of that, and they're routed, specifically so that the computers can have the power supply. And then when you have one of the primary computers operating correctly, then it's going to be supplying the actuator remote, those mentioned about the flight control remote modules. It's actually going to be supplying 60 volt DC to those modules that are installed on the actuators. If the primary computers are not operating correctly, then the secondary computers, okay, whatever that, that might be, because there's 3 on each, right? Primary computers 1, 2, 3, and then you have secondary computers 1, 2, 3. So if you have a failure of a primary computers, let's say Prim 1, then the Sec 1 is going to take over, and it's going to send that 60 volt DC to those flight control remote modules. So that's what was happening there. And then on 32, on the hydraulic system, that's electrical, and then the hydraulic system is going to be your 2 systems, your green and your yellow hydraulic system, that will be, the computers are going to be gaining the information there so that it knows at any given time, what command orders need to be sent to the actuators. What kind of information are they getting from the hydraulic systems? Well, you got 2. One is going to be your pressure status and your pressure value. Now, when we talk about value, we're talking about units of measurement of something. It's something that's quantified. So when you talk about pressure value, we're talking about a certain PSI, and that's a number. There's 5,000 PSI or whatever. When we're talking about hydraulics pressure status, that's determining whether it's high or low. Now, I know that's generic. I mean, what's considered high pressure versus low pressure, but we're talking about in any given moment in time as things are changing, how the computer is determining whether it's too low a pressure for that application at that given time. The information is coming from transducers that are on the system manifold, your hydraulic system manifold. You also have pressure switches that are also sending data to the computers. Computers are making sure that they're getting that information. And we have that. Now, if for some reason you have a primary control computer fail, then of course you're going to have your secondary computers that are acquiring that pressure status. So that's kind of going on just in case. Okay, so if let's say we have a normal operation of a primary computer that's receiving 3 sources of information for each of the hydraulic, for each hydraulic system, so that it can know what the hydraulic status is. Okay, so there's different scenarios. I'm not going to go through each one, but just as an example, if you have one pressure status, okay, so you have information, the computer does have one piece of information, which is your pressure status from one pressure switch through the secondary computer, then that information is transmitted to the primary computer through the Ailerons 429 buses. Okay, or you might have a pressure value. Remember, I said value is a quantified number in PSI that's coming from a pressure transducer. Okay, and then that information is being transmitted. The same thing through the Ailerons 429 buses. Okay, now let's say you have a failure from different sources, then the primary computer can still determine the hydraulic status in different ways. One of them is your pressure switch information. If it's lost, then you have one high pressure information and one low pressure information. Then the primary computer is going to consider the low pressure, okay, the hydraulic low pressure. So it's doing a priority order based on what conditions are present, what information is present at that time. That gives you a little bit of idea what the computers are doing. They're constantly gathering the information and then assessing, what is going to be the most important piece of information to pass on to the modules. All right, so let's go ahead. That gives you the 2 power supplies. That's your electrical and your hydraulic coming from your green and yellow hydraulic systems. Then we also have some monitoring. Obviously, we have to talk about the actual computers in a little bit more detail. And what do they look like? I mean, a box is a box, but they obviously are architecturally designed for the applications that it indicates. So on the primary flight control systems, commands and the monitoring functions, that's what we have with these computers, whether it's the primary or the secondary. And architecturally, they're actually, it's one box, but there's 2 units inside of each one of them, or that make up that one box. Those are your, and each of those units have channels, okay, or functions, and that's going to be your command and your monitoring functions, and that's for each unit. So there's really 4, or I should say 4 total functions, but 2 command and 2 mon, because there's an A and B unit for each computer, for each primary computer and each secondary computer. Each of the units are going to be in charge of dedicated actuators, and the way it's split up or segregated, what's doing what, is it's going to be one may be in charge of the left wing actuators. So it's broken up into left wing, right wing, and your tail. Okay, so left, right, and tail, as far as the grouping of actuators that are going to be affected by the primary flight control systems computers. Now, of course, your command functions are going to be sending the deflection command data to the actuator modules and the electronic modules, to make those changes. Your monitoring, it's going to be checking for the deflection order. So this is going to be the arrow going the other direction. First, you have the computers giving deflection command orders to the modules that are installed on the actuators, and then going right to the control surfaces. But what about the other way around? It needs the feedback to see what, are the angles, where they need to be, or is there a defect, on the actual physical control surfaces. So it needs that feedback, and therefore it's getting it, that comes back through the flight control modules or electronic modules, and changes that analog to digital so that the computers can actually monitor, take that data and then make the changes accordingly. Your flight control data concentrator is part of this whole commanding and monitoring of things. That data concentration is from the computers. It's also the flight control data concentrator is going to generate alerts, to the flight warning system in case there's something wrong. It will give specific information about what's going wrong, and that would be the messages that will show up on the management, central management system. And then, of course, the display of that information on the flight display, right? Your primary flight display. So it has all that going on. The flight control data concentrator, and if you've had other classes, I've mentioned that before, but these are receiving the conditions of the side sticks and the surface positions. So the warnings here will be triggered at the takeoff. If the aircraft configuration, it turns out that if that configuration is in an unsafe position, then what's going to happen was the flight control data concentrator is going to now execute certain commands where the spoilers are not going to be retracted. The trimmable horizontal stabilizer, for example, is not going to be in takeoff range. So just a few things there if there's something wrong, or have an unsafe configuration. All right, so that's on your command and your monitoring of what's happening with the control surfaces. Let's look at now a little bit more on the sensor inputs. Because they're coming from different places. Obviously, I mentioned the auto flight system, but you also have manual input from the pilot, from the side sticks. But let's kind of just name some things so you can kind of get your mind thinking of it. But you have sensor inputs coming. This is your attitude and your air data from your Ailerons, also from your remote gyro and accelerometer units. So those are going to be sending data about the attitude and position of the aircraft, and the inertial data as well are going to be sending that all to the primary and secondary computers. Now the Ailerons, just so you know, there's each of the Ailerons is connected to all of the computers. Actually, it's connected to 3 primary computers and then 2 secondary computers, and all the emissions by that system to the computers is done through the regular AirInc 429 buses, that are installed there. The monitoring and warnings, there's monitoring, of course, and that's going to be allowing for any failures of data coming from these sensor inputs. So let's say you have a problem with the Ailerons, then you're going to have, there's going to be a backup that's going to be used to monitor that data that's received, from whatever's left from another Aileron. If you have one Aileron that's not working right. There's also a warning, and that warning, the way it's spelled out on the display, is Nav Error Data disagree. And that's going to be produced by the primary flight control system in case, obviously, that there's a failure by all 3 primary computers. So that's when it's going to come on. I'm going to go ahead and mention, before we go a little too much further, I want to cover just a few test questions, or may see on the test. The primary flight control system, and just you can follow along in the handout. This is question number 1. The primary flight control system controls the speed brake and ground spoiler functions. Is that a true or a false statement? It's true. Remember, I said for the primary flight control system is everything except for slats and flaps. All right, question number 2. What are the names of the 2 functions that the primary flight control system controls? Is it lateral and horizontal, or lateral and vertical? You're correct. It's the latter answer, lateral and vertical. Question number 3, to what kind of power are the computers connected? Is it to 230 volt AC or is it 28 volt DC? Okay, it's going to be the 28 volt DC. Remember I was talking about that. Now, what are the inputs for the prims? Okay, for the prims is short for primary computers. Is it the aiders? Okay, your aiders, or I mean, is it the aiders and 6 remote gyro and accelerometer units, or just 2 RGAUs? Okay, only. That's going to be the first answer. All right, question number 5. When does the message Nav Error Data get displayed? Is it when at least one aider does not agree with the others, or when at least 2 aiders do not agree with the others? All right, the answer is the first answer. It only takes one failing in order for that message to actually show up. All right. Number 6, each unit of a computer is in charge of actuators that are divided into 3 zones. What are those 3 zones? Is it ailerons, elevators, and rudder actuators, or left wing, right wing, and tail actuators? Okay, remember I said it's the left wing. Remember I said left wing, right wing, and tail. So that's the answer. All right, let's go ahead and go back to our lesson here. So just remember that Nav Error Data disagree will show up if you have a failure of one of the ailerons. And also, the primary flight control system is used to consolidate the parameters of those ailerons to the primary computers, and that's actually used to compute the laws. So it's really, really critical the way that it's taking in those sensor inputs and, ensuring that it's getting the right data for one in order to give the commands. You also have what's called a load alleviation function. That's not done by the secondary computers, by the way. That is strictly by the primary computers only. You also have the multifunction probes that send the data for the load alleviation function computation and that goes to their respective aileron and also to their respective primary computer. What's the load alleviation function? What is it? Alleviating load for what? Because that's what that is. Okay, we're talking about the protection for the wings, so that there's not, an extra load or a burden on the wings during when it's moving. When it's flying and you have gusts of wind that can put pressure on the either underneath or it could be on top. It's just if you have high winds or gusts, it's going to create a load on those wings and kind of tax it. This load alleviation function is there to protect the wings from those types of loads. And what it's doing, it's just modifying the span-wise lift distribution with the ailerons and our spoilers, upper deflections. So it's kind of reducing that for a little while. Basically, it's a way to keep the wing from bending too much. Okay, so it has some flexibility, but wherever they can utilize the other control surfaces to alleviate some of that, well, that's what we're talking about here. That's what that load alleviation function is doing. It's utilizing other control surfaces to help reduce any load that may be existing there on the wings. All right, let's go ahead and now cover the different functions. Remember I said there's 2, right? I said there's lateral and there's your vertical function. And that your lateral function, when we talk about the 3 different axes of an airplane, we have your roll, yaw, and pitch. Okay, your roll and your yaw go side to side, which is your lateral function. And then the last one is your vertical function, which is your pitch, which knows, aircraft knows up or down. And that's what we're talking about. So let's go ahead and go a little bit in depth with that and see what is it that we're talking about. What do you need to know about this? The primary flight control system's lateral function, this is in particular I'm talking about the roll right now, is it's able to be done with what control surface is? Okay, do you know? Okay, it's going to be your ailerons and spoilers. Your flight spoilers, by the way, are going to be employing as, I mean, it's in conjunction with the ailerons, but it's kind of like a supplementary, but it's still important to, you know, and has an important function with, you know, as in conjunction with the aileron function. So you have inboard ailerons, your outboard ailerons, and then you have spoilers 3 to 7. So when it comes to roll, the spoilers involved are going to be spoilers pairs 3 to 7. The roll command, how does it even get started? How does the plane even begin to roll? It has to be given a command to do so. And that's going to be started obviously with the auto-flight system or the side stick units from pilot input. That's when it starts, and it's all that information, again, like I said, is all sent to the computers. Okay, both your primary and your secondary computers. At the same time that it's getting this input from your AFS, your auto flight system, or manual input, it's also getting data from the Ailerons. Remember I said the gyro accelerometer units, okay, your RGAUs, and your Ailerons for attitude data, etc., okay, and inertial data. So it's getting all of that and computing the deflections for the ailerons as well as the spoilers. What's happening technically, okay, with the ailerons when it's its job is to do the roll for the airplane? Well, the ailerons are moving a transducer, okay, it's a position transducer, so that it can give a surface position feedback to the computers, okay, through, obviously, remember I said that translator, which is your remote control, or excuse me, your flight control remote module, or your electronic module. And that's how that's working. It's using transducers. And what happens if we have your outboard, remember I said you have inboard and your outboard ailerons. If you have low speed, if the plane's at a low speed, then all the ailerons are being used. If the aircraft is at a high speed, then not all of them are going to be used. It's only going to be the inboard ailerons in that particular instance. And so then what's happening with the outboard ailerons at high speed? Okay, they're maintained in a neutral position. Remember I said this is about position transducers and having it maintain a certain position, okay, or giving command to the actuators, you know, obviously then to the control surfaces, mainly we're talking about ailerons. And the inboard ailerons are going to be, you know, having different deflection angles. But at high speed, the outboard ailerons are kept in that neutral position. Okay, and that's usually above 240 knots. Your spoilers, okay, that was ailerons. Now I'm talking about spoilers. Your spoilers 3 to 7 move upward during the roll maneuvers, so that it can just kind of give remember I said it was like a supplementary. It's augmenting the control of what the ailerons are doing. So roll, right? So it's just augmenting or supplementing, but it's helping with controlling even further the roll from left to right of the aircraft. There's also what's called aileron droop. If you have the flaps extended, I know this is, you know, we'll get to flaps later when we get into another session, just strictly talking about flap control systems. And when we do that, we're going to be talking